Okay, let's dive right into this. Welcome to today's Explainer, where we're going to be looking at the actual future of cloud security. Now, I want you to picture your typical enterprise AWS cloud environment. Don't just think of it as a bunch of abstract servers, right? Think of it more like a massive, high-tech, maybe slightly chaotic underground laboratory. You've got, 1,000 different experiments running at once. Production workloads, development servers, shared services, and it's all constantly changing. Keeping a lab like that secure, it is an absolute nightmare. But today we're going to explore a truly fascinating blueprint for putting that security on autopilot, and we're doing it using custom enterprise large language models.
So picture this scenario for a second. It's Monday morning in our underground lab. You walk in, you sit down with your very first cup of coffee, and suddenly the red klaxons start blaring, flashing lights everywhere. A whole cascade of security alerts has just rolled in from AWS Security Hub and guard duty. Now, normally, you'd be bracing yourself for literally hours of tedious manual investigation. But ask yourself, what if, instead of you frantically running around pulling levers and putting out fires, you had a supercomputer that didn't just tell you about the mess, but actually understood it and just fixed it automatically?
Because let's be honest, here is the painful reality of cloud security today. 247. Imagine discovering you have 247 critical security findings in your AWS environment right this second. One S3 bucket is suddenly publicly accessible, 3 EC2 instances have critical vulnerabilities, an IAM role got granted way too many permissions, and a security group is out there exposing SSH access to the entire public internet. Right now, a human engineer, maybe you, has to manually investigate every single one of those 247 alerts before even thinking about fixing them. Honestly, it's just completely overwhelming.
So to solve that chaos, we need a fully automated, highly deterministic workflow. We don't just want to find problems anymore. We want a smooth, reliable system that can detect the issue, completely understand the context, decide on the absolute safest action, remediate the vulnerability, and then finally verify that the fix actually worked. Getting all the way from detection to verification without a human having to manually connect the dots, well, that's pretty much the holy grail of cloud security.
To make that sequence a reality, we need a brain for our laboratory. Enter the Enterprise LLM Supercomputer. Now, when I say LLM, I want to be very, very clear about what we're talking about here. We are definitely not talking about unleashing some magical, unpredictable robot with unrestricted admin access to your AWS environment. No way. That would be a complete disaster. Instead, think of this as a highly focused reasoning engine. We're building a strictly controlled security orchestration layer around the AI, using it only for its ability to comprehend really complex, overlapping data.
The leap from the past to the future here is pretty stark. You see, traditional automation is kind of brittle. It basically says, if we find this specific finding, then execute this exact action. And hey, that's deterministic, which is great for predictable problems. But as we know, enterprise environments are rarely simple. They are absolutely full of exceptions, like a developer might actually need a specific port open for a temporary production patch. LLM-powered automation doesn't just blindly follow an if-then rule. It takes the finding, adds the enterprise context, evaluates the risk, and outputs a reasoned recommendation. It can actually interpret the gray areas of your organization.
But you might be wondering, how does the AI actually know your organization's specific gray areas? Well, it uses something called enterprise RAG, or Retrieval Augmented Generation. If our AI supercomputer just relied on its general internet training, it would make terrible decisions about your highly customized lab. RAG is the mechanism that essentially feeds your organization's unique, highly specific rulebook directly into the model at the exact moment a security alert happens.
And what exactly are we feeding the supercomputer through this RAG process? We're talking about your internal security policies, your specific AWS architecture standards, incident runbooks, CMDB data showing who owns what app, and even previous remediation records. So instead of the AI asking a generic question like, how do I fix this AWS finding? It asks, given this specific enterprise environment, these specific runbooks, and this exact application owner, what is the safest remediation? It knows exactly what is safe to modify because we literally just told it. However, even with all that amazing specific context, we are still dealing with an AI experiment here. And any good underground lab needs blast doors, right? We have to build rigid AI guardrails. This is arguably the absolute most critical part of this entire explainer. The guiding principle here is separation of responsibilities. The LLM is allowed to reason about the problem, sure, but a completely separate policy engine decides what the AI is actually allowed to do.
Let's rapidly fire through these 5 layers of blast doors because the sheer amount of security wrapping this AI is massive. Layer 1 is IAM permissions. We give the remediation role only the exact permissions it needs. Absolutely no administrator access allowed. Layer 2 is resource restrictions. The AI can only touch approved accounts and regions. Layer 3 is the policy engine, strictly dictating rules, like always requiring manual review for production networks. Layer 4 is a confidence threshold. Only high-confidence, low-risk actions get automated. And Layer 5 is blast radius analysis, understanding exactly what application breaks if we make this change, and if we can roll it back.
So the crucial point here is this: confidence is not authorization. I absolutely love this quote. You must never, ever trust the AI models simply because it produced a highly confident answer of 99%. Adding an LLM introduces severe risks, things like prompt injection, hallucinated remediations, and model manipulation. A confident AI is just a confident AI. It still has to pass through every single one of those rigid authorization guardrails we just talked about before it can touch a single AWS resource. Which brings us perfectly to the ultimate failsafe, the human in the loop. For high-risk production-level changes, a human security engineer always remains in control. The AI does all the heavy lifting, right? It detects the public SSH access, retrieves the company policy, writes up a detailed explanation of why it violates standards, and prepares the exact API code to fix it. But then, it sends that entire neat little package to an engineer. The human just has to review the AI's perfect homework and push the giant red Approve button. This isn't about replacing security engineers. It's about getting rid of that repetitive, mind-numbing investigation work.
Once that human engineer hits Approve, we flip the switch, and the automated execution layer takes over. The approval triggers AWS step functions, which orchestrates Lambda functions to execute the fix strictly using official AWS APIs. I really want to highlight a massive security win here. No engineer is manually logging into the console to click around, there's no messy copy and pasting of code, and most importantly, there are absolutely no risky, arbitrary shell commands being generated and run by the LLM. It's just clean, structured, predictable API execution.
But, hey, the job isn't done just because the API fired. Our system acts like a disciplined scientist. It automatically checks its own work against a strict verification checklist. It verifies the security group rule was actually removed. It forces AWS Security Hub to rerun its evaluation. It confirms the original finding status has changed to resolved. It checks the application health to ensure we didn't accidentally break the server. And finally, it records the remediation, the whole shebang.
And recording that remediation is absolutely vital for compliance. This audit table essentially becomes the permanent logbook of our lab experiment. Every single AI decision must be fully auditable. We record the original finding, the context, the exact policy the AI retrieved through RAG, the confidence score, the human's approval sign-off, and the exact API action with a timestamp. This creates a flawless, indisputable chain of evidence for your auditors. It proves exactly who, what, why, and how a change was made in your cloud.
Now, zoom out with me for a second, and imagine scaling this intelligent, autonomous system across your entire AWS organization. The potential here is absolutely staggering. You can have this AI continuously monitoring IAM for excessive permissions or dangerous trust policies. It can watch S3 for public buckets or missing encryption. It's keeping an eye on EC2 instances for unpatched vulnerabilities and constantly scanning your network for overly permissive security groups. It's literally like having a tireless, super genius security team working 24/7 across every single corner of your infrastructure.
Which brings us to our final, evolved blueprint. We started with a simple 5-step process, but look at how it's matured now. Detect, understand, decide, approve, remediate, and verify. This perfectly balances incredible AI intelligence with strict human control and rigid organizational guardrails. The LLM provides the intelligence, the policy engine provides the control, AWS provides the infrastructure, and automation provides the incredible speed to resolve threats in minutes instead of days.
As we wrap up this explainer, I want to leave you with a final, somewhat provocative thought. The future of cloud security isn't just about finding more vulnerabilities. We already have more than enough alerts to drown in, right? It's really about drastically reducing the time between detection and remediation. So, looking at the speed and complexity of modern threats, how quickly does your organization need to adopt autonomous remediation just to survive the cloud era? The technology to build this AI security agent is already here today. The only question is, who's going to build it first? Thanks so much for joining me on this deep dive, and keep learning.